All right, so let's do some examples. I want to know if this relation is a function. So first of all, what on God's green earth is happening here? Okay, so I've got some sort of equation. Its name is C, and C equals these 4 points. So notice I've got curly brackets, and those curly brackets mean that I've listed everything on the inside. So it's listable. It's a small enough quantity that I can list it. So if I want to know if this is a function or not, based on what I learned a while ago, I just need to look at my x coordinates and see if any of them repeat. So when I look at this, I see a 10, no, no, no. I see a -3, no, no, no. I see a 1, no, no, no. I see a 3, no, no, no. So no x values repeat, so this passes, this works. So what happens rapidly if we plotted it? So I've got 10, 4. I've got -3, -3. I've got 1, -1, and I've got 3, -10. Okay, not drawn to scale. So if I draw an infinite number of vertical lines, that one will hit. Draw an infinite number of vertical lines, that one will hit. Infinite number, that one will hit. Infinite number, that one will hit. So each vertical line hits the graph a maximum of once. So this is a function. So he passes, okay? So what I have then is determine if I've got a function or not. So if I've got a -1, comma 4, I've got a -2, comma 8, and I've got a -3, comma 12. So first of all, the way that this is organized is just an XY table, okay? So I just want to know, do any of my x's repeat? Do I have any other -1s? No. Do I have any other -2s? No. Do I have any other -3s? No. So since none of those repeat, this passes. So your answer is yes, it is a function. Okay? So what happens if I have a diagonal line? So now we've gone from points. So do my x's repeat? And now we're going to look at a picture. So if I've got a diagonal line that looks like this, okay, I would like to know, is that picture a function? So remember that this arrow means that this goes on this direction for its entire life, and then it goes down this direction for its entire life. So it hits once way up there, hits once. So all of these just hit one time. So since each vertical line will only hit the graph once, or a maximum of one time, this also passes. So he is also a function. So now I want to kind of sort of explore a little bit more and say, what's the domain and what's the range? So for domain, I have a picture. So tell me how far left it goes. So remember, your x's will go left and go right. So how far to the left will that line go? Well, it's going to go forever left. It's also going to go up or this direction, but it's going to move forever to the left. So my domain is going to go forever left. And then as I'm reading it from left to right, how far right is it going to go? Well, it's going to go forever right. So your domain is from -infinity to +infinity. That's interval notation. And you'll find out later we're lazy math people, so we'll actually use a capital R with a double vertical bar. That means all real numbers. Okay, so this is the long way of writing it, which is the way you're expected to do it, and this is the shortcut that you'll get to later. So what's your range? Okay, so the question is, how far down is this thing going to travel? So notice it's moving in a downward motion this way. How far down is it going to go? Well, it's going forever down. Okay, so if it's going forever down, then your range is going to start somewhere down in -infinity. And then how far up is it going to go? It's going to go forever up, which means this thing goes up to +infinity. So once again, at some point, you'll be able to just say it's all real numbers. Okay. So we have another example. We have a sideways parabola. So here's my parabola. He is sideways. The first thing I want to know is he a function? So when I draw these vertical lines, it does not hit the picture. Doesn't hit, and then all of a sudden, a single vertical line is going to hit multiple times. So he fails. So what that means is a single x value. So let's just pretend, because I didn't label these. a single x value of 2, this could be positive 4 and negative 4. So the point 2, or an x value of 2, hits or corresponds to 2 y values at the same time, so he fails. So is he a function? No, he is not. You've got repeating x's, which means he fails the vertical line test. So now I would like to know, what's my domain? So how far left does this thing go? Well, I don't have it at all. He starts at 0. So can he be 0? Absolutely, because there's a point right there, okay? So how far to the right will he go? Well, he's pointing in that direction. He's going to go forever right. So your domain is from 0 that he can touch out to positive infinity, and the infinities always get soft brackets. What's your range? So remember, how far down is this thing going to go? Well, this is going in a downward motion. It's just going to take a while to get there. So your range is going to go all the way down to negative infinity, and then it's going to go all the way up, because this arm is going to keep going upwards. So that arm is going to go up into positive infinity, and what shortcut do you get to use at some point in your life? All real numbers. Okay, so let's try something else. So now I am told that I've got a relation. So we've done points, we've done pictures, and now we're going to do equations. So in the last video, I told you that I give you some shortcuts. So one of my shortcuts is looking to see what the issue is. Okay, so is there anything that's going to cause this equation to go bad? Well, remember, we do not want negatives underneath that radical, because if we generate negatives under a radical, we go to imaginary number land. So immediately I know that I can't use everything out there. I've got to restrict it. So here's your method. I have a square root. I'm going to take the argument, which is the stuff under to the radical, and I'm going to say you need to be positive or equal to 0. So all the numbers bigger than 0 are positive, but you can also be 0. Why? Because the square root of 0 is valid. The square root of 0 is 0. And now I'm just going to solve. So what's my strategy? Take the argument and say greater than or equal to 0 every time, because you want it to be positive, but it can also be 0. So now I'm going to solve. So I'm going to subtract 4 from both sides. So I've got x is bigger than or equal to negative 4. Okay, so how do I write that in interval notation? Well, what number am I interested in? Negative 4. I want everything bigger than that, so there I go. And I'm allowed to touch the 4, so there I go there. Okay, so what is my domain? My domain begins at negative 4 and shoots off to positive infinity. Okay, now that we know that, let's try some samples, because now we need to know what our range is. So our range is the y values that will be produced. So I'm just going to start grabbing a couple of these things and seeing what happens. So if I shove in a negative 4, 4 plus negative 4 is 0. What if I grab a negative 3? 4 plus negative 3 is 1. So I went from negative 4, 0 to negative 3, 1. Okay, what happens if I shove it? I'm just grabbing numbers that are in this interval. So let's grab a 0. What happens if I shove in a 0? 4 plus 0 is 4, okay? And so that's going to give me a 2. So notice that this is growing, and it's just going to keep growing. So what is your range? What's the very, very lowest y value you can plot? Your very lowest y value is at 0, and then how far up is this thing going to go? It's going to go up to positive infinity. So there's your domain, and then there's your range, okay? So let's try a couple more. What if I have something like this one? Okay, so I have 6 over 9 minus x. And I want to know what the domain and the range is. Okay, so is there anything weird that will happen? So on the last one, I had a radical. And for a radical, I didn't want it to go negative. On this one, I don't want to divide by 0. Okay, you never want to divide by 0. That's undefined. So what I'm going to do, my strategy to determine what my domain is, I'm going to assume it's all real numbers. Okay, unless I have an even root, which I had on the last one. This is an even root because it's a square root. Okay, or I have variables in denominators. So if I've got a variable in the denominator, I'm going to take it and say, boy howdy, you better not be 0. because I don't want this to go to 0 and then divide by 0 is undefined. So now I'm just going to add x to both sides. So that gives me 9 had better not be x, or x had better not be 9. X can be anything else out there, but not 9. So what does that look like on a number line? I'm interested in 9, but it better not be 9. But it can be everything this way, and it can be everything this way. So where does your answer start? For your domain, your answer is going to start in negative infinity, and it's going to come all the way up to 9, but it will not touch the 9. Okay? It's going to hop over it, and it's going to say, okay, pick back up it on the other side of 9. Don't touch it. Okay? And then go shooting off to positive infinity. And then what's the cool little symbol you put here? Union. Okay? So now I have that. So what's your range? Okay, so on the last one, I just took a couple of points and tried to figure it out. Well, on this one, it's a little bit easier, actually, because this is a fraction. So we're kind of interested in zeros. So your denominator cannot equal 0 because it'll be undefined. But look at your numerator. Is it possible for this fraction to equal 0? Okay, the only way for a fraction to equal 0 if its numerator will equal 0. Well, I cannot just say poof, change that 6 and do a 0, which means it's impossible for this to go to 0. So why am I pulling this out of thin air? Because I'm teaching you a concept. For if you're looking at domain and range, when you've got a fraction, for your domain, take your denominator, say you better not be 0 and solve. Okay. For your range, look and see if you can make your numerator equal 0. Well, I can't, which means y cannot equal 0. It's impossible. So your range cannot include 0. So if that's the case, my range is going to be everything but not 0. Everything but not 0. Okay? So I keep saying okay. All right, so let's try a couple other ones. So now we're going to say I have done the work and I have determined that something is or is not a function. So I'm going to change it from a relation notation into function notation. So this says I am a function. Okay? And so now that I'm a function, this is what it looks like. So I'm a function. My name is G. I play with x's. So now I want to say, okay, what is g of negative 4? So what did you do? What you did was you dropped the x, and what did you put in its place? You put a negative 4 in its place. So be very careful with your signs. So this square is only attached to the x. It's not attached to the negative. So that negative is coming along for the ride. Instead of an x, what am I going to write? Negative 4. And then I'm going to square it. Plus 6 times, instead of an x, write a negative 4. And then I got a plus 3. So this negative is coming along for the ride. So negative 4 times negative 4 is 16. So this negative comes along for the ride. That turns into 16. This is a minus 24 and then a plus 3. So negative 16 minus 24 is negative 40. Plus 3 is negative 37. Now let me tell you some magic. You just found a point. If you shove in an x, you just found the y. So you just discovered that the point, negative 4, negative 37, is on that graph. Okay, your answer is negative 37, but you just found a point on the graph. Okay, so let's try another one. I have f of x is going to equal a negative 8x plus 6. And I want to know what f of 1/2 is. So what is f of 1/2? Well, what did I do? I swapped out an x for a 1/2. So I'm going to kill my x's. So negative 8's coming along for the ride. Slap in a 1/2 plus 6. So what is half of negative 8? It's negative 4. Plus 6 is 2. So your answer is 2. But really and truly, what did you just find? You just found out that the point 1/2, 2 is on the graph of that function. Okay? What happens if we go a little bit more analytical? So I have f of x equals negative 4x plus 5. And I want to find out what is f of negative x. Okay? So what am I swapping out? I'm going to kill the x, and I'm going to put in a negative x. And you're like, who cares? It's just a sign change. Well, here's my question. Would you rather have a positive 1 million in your bank account or a negative 1 million in your bank account? That's a big difference. Okay? So it's not just a little piece of ink. It has some power to it. So instead of writing an x, what am I going to write? I'm going to write a negative x. Plus 5, so negative 4 times negative x is positive 4x plus 5. So I didn't change it into a number, I just got another formula. Okay, so I changed something about it, but I didn't evaluate with a number. Okay, so let us try, I'm going to go over a couple minutes on this one so that I can narrow this down to just one more video. So let's do this one. I've got f equals, and then I've got a list of coordinates. So my coordinates are a negative 4, 3, a negative 9, negative 3, and a negative 3, 5. Okay? And I want to find f of negative 3. So first of all, what is it telling you? What it's telling you is I am a function. Okay? Why didn't I have f of x? Because I don't have any x's over here. All this is 3 points. That's it. Okay? So 3 points. I want, what would normally be here is an x. Well, I want a negative 3. So if I shove in a negative 3, what pops out? What pops out
text message
is a 5. I have a text message. I am so sorry. Okay, so what I have then is your answer is 5. So if I had asked for f of negative 4, your answer would have been 3. If I'd asked for f of negative 9, your answer would have been negative 3. Is this a function? Yeah, it is. Because none of your x's match. So we're going to do a few more examples on a final video.